In this video, we are going to have a look at how to work out a secondary port calculation. The question is, what is the time and height of high water in Glasgow on the 20th of October 2020? We're going to use the standard port tide information for Greenock, and if you want to work through it with us, we need the 2020 almanac, a secondary port calculation template, and a pencil and ruler. Before we dive too far into the secondary port calculation itself, I think it's worth taking a little bit of time to have a look at what they actually are and what they mean. So we've used the example of the Clyde here. And as we can see, if you can follow my cursor, we have Greenock in red. This is the standard port for the whole of the River Clyde. All these other smaller ports, Portavadie over here, Tarbert, Largs, Rothesay, Fairley, for example, are secondary ports. The tide, when it comes in, if you follow my cursor, runs this way and goes up the Clyde, which means it's going to hit Fairley, Largs, Kip, to pluck 3 examples, before it hits Greenock. So the tide will arrive at those ports before Greenock, so the correction from Greenock has to be minus. The likes of Gairloch Head, Rue, Dumbarton and Glasgow all lie after Greenock, which means the correction from Greenock to those secondary ports, you're going to add the correction on. It's going to be greater. The information itself can be found in the almanac, and this page shows an extract from the almanac, and it gives us a whole number of bits of information. It says up here that we have a standard port for Greenock, which we knew from the previous page. This says that if high water was at midday or midnight at Greenock, the differences for Glasgow, which is what we're going to work out, would be 25 minutes later. If high water was 6 AM or 6 PM, the differences to Glasgow would be 15 minutes later. If high water height was 3.4 metres at Greenock, the difference to Glasgow would be plus 1.4. 2.8 metres at Greenock would be plus 1.1. 1 metre at Greenock would be plus 0.8. And 0.3 would be plus 0.4. That's all very well and good if our times and our heights end up on those exact times or numbers, but rarely is that the case. To actually work out the calculation, firstly, we need the information for that day. So the 20th of October, and we can see we have our information there. We keep this as UT, so we do not add the hour on until we've done the secondary port calculation. So we have a high water of 1441, and that sits somewhere between 1200 and 1800, which means the correction will sit somewhere between plus 25 minutes and plus 15 minutes. So what we need to do is we need to expand the 2 columns out. Up the left-hand side of this diagram, we go 12 up to 1800, and I've chosen to miss a line for every hour. So 12 up to 1800. On the bottom, we start with 25, and you can really create your own scale here. It just needs to be the same the whole way along. And I continue along until I get to 15 minutes. You see my first red dot keeps the 12 and the 25 together, and this is really crucial because we have to keep these columns of information together. So 12 and 25, and then 1800 and 15. So you can see our two red dots over here. Draw a line between them, and then the last bit of the information is to go in with our time, so 14:41. And then meet the red line and then down, and we can see our correction is going to be somewhere between 20 and 21 minutes. To calculate the high water height correction, we need to expand the high water height information, and we can see in the top right hand corner that is 2.8 to 3.4 meters. So up the left hand side we go 2.8 up to 3.4. Now if we remember back to our tidal information, we know that the high water is actually 3.6 meters on this day. The benefit of this grid version is it's easy to add other information in and expand the information. So we've added another couple of lines in, 3.5 and 3.6. On the bottom one is the high water height correction, 1.1 to 1.2, 1.3, 1.4. And we know the information is going to be bigger, or the correction is going to be bigger than 1.4 meters, because the high water height at Greenock is bigger than 3.4. So we've added another one in there as well. Match the two columns up. We've got our red dot in the corner for 1.1 to 2.8 meters, and we've got our other red dot for our mean high water height at 3.4 and the correction to 1.4. Draw a straight line and extend it past, and then we go in with our high water height 3.6 meters, and then we end up with a correction of 1.5. Our low water height is done much the same way. 0.3 to 1, but this time because the number's going down, we started with 1 in the bottom left hand corner and gone down to 0.2 because we know we've got a lower tide information than 0.3. 0.8, 0.7, 0.6, 0.5, 0.4, 0.3. We need to match the two columns up as we always do. Draw a line between the two, and then we go in with our low water height, 0.2, and we can see the correction is somewhere between 0.3 and 0.4 meters. So once we've done our three calculations, this is the information that we end up with. Our standard port time was 14:41, with 20 minutes of correction on, which means our UT high water at Glasgow is 15:01, and because we're still in summertime, we add 1 hour on. 3.6 meters at Greenock, adding 1.5 meters of correction on gives us a high water height of 5.1, and a low water height of 0.2, adding 0.3 meters on gives us 0.5. And that is our second report correction complete.